The standard approach to online education usually involves uploading massive PDFs and hour-long video lectures into isolated digital folders and calling it a course. This is driven by the transmission fallacy, the assumption that moving didactic, physical materials to a digital screen automatically transfers that knowledge into a learner's brain. In reality, this fragmented architecture shifts a massive cognitive burden entirely onto the student. Novice learners are left to independently sift through disconnected data, leading directly to a collapse in engagement. Replicating a physical lecture hall inside a learning management system creates a static repository of data rather than an environment for active learning. Relying heavily on explanatory media creates a counterintuitive problem. Highly detailed recorded lectures often degrade the learning experience for novices, a phenomenon known as the expert reversal effect. Passive observation fails to create stable neural connections. When faced with fragmented digital facts, learners struggle with the binding challenge, where they fail to integrate these pieces into a cohesive mental model. This model illustrates the core problem. At the center is the learner, disconnected from the outer rings of the instructional environment. Effective online education requires a shift toward engineering precise, multidimensional learner-content interactions. Deep cognitive engagement requires strict structural design. It is never an organic byproduct of a student's natural motivation alone. Instructional designers must navigate 5 interdependent factors before a single piece of content is uploaded to a server. These elements, learner characteristics, technology affordances, instructional strategies, situational factors, and learning objectives, are constantly interconnected. Change in one node inevitably forces an adjustment in the others. Managing these constraints requires executing 5 specific shifts in digital pedagogy. Firm. Without these foundational constraints defining the boundaries, course design inevitably returns to unguided data dumping. The first shift tackles the binding challenge by moving from fragmented content modules to explicitly integrated learner-content interactions. A pedagogical wrapper encapsulates these elements. By providing a structural header that answers the what, why, and how, the instructor makes the relevance of the material immediately obvious. The second shift moves from broad brush information dumps to finely targeted, highly specific conceptual content. Designers must remove extraneous data and focus explanatory content exclusively on the core concepts and principles necessary for the task at hand. This targeted approach ensures the learner processes the significance of the information instead of sifting through an avalanche of data. The third shift moves away from single media reliance toward hybridized media structures within a single module. Instructors are often trapped by functional fixedness, where they isolate media by type, grouping all videos in one folder and all readings in another, rather than blending them for cognitive impact. A more effective hybrid sequence uses text for slow, deep conceptual processing, reserves video for dynamic processes, and ends with an active decision node. This leads to the fourth shift, moving from abstract definitions to contextualized, real-world learning. The 7 C's framework provides the structural logic for this shift. By combining challenge, context, characters, and choices, instructors create interactive scenarios that anchor theory to practice. Hybridized scenario-based design takes inert knowledge and transforms it into actionable, high-retention skills. The final shift moves from pure cognitive dominance to a design that accounts for emotional and behavioral interplay. While learner motivation is often viewed as the SPUDA's responsibility, it is actually a structural design requirement of the course itself. Keller's ARCS model, attention, relevance, confidence, and satisfaction, defines the emotional architecture required to sustain mental effort. By introducing mystery or moderate complexity before the learner interacts with the content, instructors induce a state of curiosity that prepares the brain to acquire knowledge. Integrating these emotional triggers with opportunities for social discourse ensures that learners don't just process data, but engage with the material across every learning dimension. This brings us back to the full model, illustrating the target state for digital pedagogy, a multidimensional learning experience. Notice the outward arrows. Effective scenario design and pedagogical wrappers activate the cognitive, emotional, behavioral, and social dimensions simultaneously. This holistic activation closes the knowing-doing gap, the disconnect between possessing information and possessing the ability to perform a task. The density and context of interactions define the quality of an online course, regardless of the volume of resources provided. Instructional design must move past simple, static data delivery and instead focus on architecting multidimensional experiences that demand real action.